We are here a little bit early. I wanted to give people a chance to climb on in so they could see this fan either do what it's supposed to do and or explode and just go everywhere. I don't know if I should get a wide angle or not, to be honest with you. Let's try and get this level so you can see what's going on. Chains are all set. Everything is as good as I can get it right now. So I'll give people a chance to kind of mosey on in while I grab the tablet so I can see who's on. All right. Hey, how's it going? What's up, flies? Glad you could be here. While we're kind of waiting for people to kind of get here, you had mentioned something on that last run, and I think I answered it. But it was something about some noise you heard. Could you tell me what you were talking about? I think you were talking about a noise of some kind. Feel free to drop it in the comments and I'll read it. Yeah. PXD. Noise comes from the gears. I'm not sure what exactly causes this kind of noise. Oh, well, the reason why is because these teeth were built to a CNC tolerance and it's FDM printing. So I figured a little bit more material rather than less would make the meshing a little bit tighter in the beginning, but they would wear in. And what you're hearing is the teeth kind of slip into each other in a sense. So it's kind of loud, but it does smooth out. I think it will smooth out after, a couple of runs. Today is to see how long this can run now with the new mount. So I kind of redesigned the mount a little bit to make it a little bit more robust at the place where it did break. That's not to say that it won't break again, but it is an improvement. And I've kind of run a couple of screws into the casing here to keep it from, because I noticed during the last run, it sort of, even though this was just sitting in here, and it was the case was bolted together, that was kind of rotating inside there. So I ran some self-tappers in to the casing. There's holes here for the casing. That's why these ports are here. Because this ductwork can actually adapt to the front mount that I have on the original Stubby fan V1 and run a direct drive if I want to do a direct drive from the front. Kind of like the way this one was designed right here. This one had a direct drive. And this one is another perfect example of the direct drive front end, but it's not this mount. It's a different mount for a direct drive system. So it's more just flat bands, and then the motor mounts back here. The motor actually indexes directly into the front of the fan. Not on this one though. This is kind of the same principle as this, except now it has a rear drive system, which is much noisier. The reason why is because I can't find anyone to successfully do this floating gear. Because as you can, I don't know if you can see it in there, but the actual planetary ring gear floats inside the box. So instead of being pinned down with a double stacked gear like I had before, any kind of flex or movement forward from the fan is mitigated by the gear actually floating inside that box. So it's indexed where the ring gear is solid and in place, but other than that, it is a floating gear. And I'm gonna set up another motor to run this. But I would like to get another Flip Sky motor, and or even something with maybe even a lower kV, just to see what we get out of it. Because what I'm running it right now is a 6374 190 kV. CJ, I'm waiting for everyone to kind of roll in. Buck, welcome back. We're gonna see if people actually drop by to see this one. It could be a short live, it could be a long live. The idea is you guys ask questions about what I'm doing. I run it till its batteries are dead or it explodes, and then we talk a little bit more about it, and then everyone leaves, and I get 2.5 watch hours. Welcome to the YouTube nature of the beast, right? One day you too can get your Stubby fan mug from DPC. Buck. Come on, Buck. Making me want to go buy a Volkswagen now. So we said 7 o'clock. So at 7 o'clock, we'll either power it up or talk. What do you guys want to do? Actually, it'd probably be a good idea to get it run. We'll get set up and run for kind of a low RPM test run. Just to see how she's sounding now, as opposed to yesterday. So let's go ahead and get that started. And we will see what happens. So hold on, I gotta plug in my RX. All right. Explain that one to me. Does this to me every single time. Okay, let's try that. Okay, one more time. No. Now that's something that's weird to me, having to basically calibrate the thing every time I plug it in. All right. See how she's spinning at low, very low throttle. Warm up the gears a little. Yeah, that knocking does sound like an imbalance. I think it's the gear. I had the same problem with the forward planetary gear. I think these gears need to float to be more effective, or be CNC'd out of, straight up metal, which is what I designed them for. But what we're going to end up doing is running this thing until it breaks. Hopefully the new motor mount is a little bit more robust than the other one. But we'll see what happens. Hey, Sags, how's it going? Glad you could make it. So we're going to get started here shortly. We're just kind of... I'm kind of warming up the gears. So... taking a drag, waiting for everyone to get here. So what we will do is run it until it fails, and if it fails quickly, it fails quickly. If it lasts longer than last time, so great. But we're going to see what happens. So this is a, if I got my teeth count right, I can't remember off the top of my head. I think it was 8, 8, and 22. And I think it's a 4-to-1. And I know I have 8 teeth on each one of the planetaries. So, and the sun gear. So I think what's gonna end up happening is, this was just sort of something I kind of threw together on the last minute when the front planetaries didn't work out as well in metal. So, yeah, that laser centering, it's got way too much offset for precision gears, and that kind of ticked me off. You know, you would have thought that the engineers over there where they had it done would have told me that and said, hey, you know, this is probably not going to fit, but we'll take your money and print it anyway. I'm thinking the same thing. I think so too. I think maybe it's probably going to break at the same point, and that's the mounts. It may last a little bit longer. I don't know. And we may have another failure point. Regardless of what happens, it's basically all data collection at this point. And to be honest, if what I wanted CNC'd out of an alloy was basically already CNC'd, we wouldn't have this issue. We wouldn't have this issue at all. Even with the gears that I have in there now. You can kind of hear it a little bit. But you got to remember, those are FDM gears, big FDM gears, a lot of tooth contact. They're riding on bearings. They're being pushed by carbon fiber rods that go through the collet that's attached to the engine. You've all seen the design before. So basically, you know, it's FDM printing, okay? And it was designed for CNC. So, and the reason why is because I didn't want to have to design it twice. The funny thing is, that's right there, that was 0.72 amps on the draw. And we have 47 volts still, so we're good to go. Now this... that was 1.65 amps. 1.65 amps. Just to get those RPMs out of it. So... okay, I guess what I'm going to do then is what I set out for, and I'm going to go over here to a safe place. We're going to spin it up a little bit faster. See what happens, see what breaks first. Everybody ready? Let's see some hearts, let's see some celebration. Let me do a temperature check. It's not that bad. Lose a wire? No, didn't lose a wire. Hold on. No, that's odd. The motor isn't even hot. 83 Fahrenheit. Check it. Well, everything still spins freely by hand. That's weird. Okay, let's unplug it because we still have 45 watts. Let's reset it real quick. It smelled like it burnt something, but at 85 degrees. Well, that makes no sense. Well, that is the strangest damn thing. I think we lost that motor, people. That is so weird. She got up there a ways, though. Well, it sounds like that because of the gears. It's going to be really loud for those gears. Just because of how big they are. The ESC's not that warm. I mean, it's a little warm. $107. But that's nothing really. Fahrenheit, 107, 101, 107. That's well within operating temperatures. I don't know. Let me take a look. Well, the ESC didn't go. I mean, let's find out. We can go straight 22. I will hook it up to, where's the other motor at? Here it is. And we'll just see how those want. We'll see if something happened. I think the motor failed though, which is kind of odd. That motor shouldn't have failed like that. No, we're not going to push it with this motor. We're just going to test this motor with it. It's a 22.2 volt, so it doesn't matter which direction I plug it in. So chances are, go straight in, we'll hit 22. Since this is a 6S motor, I don't want to blow it up. No, I guess I'm guessing it's the motor then. Yeah, because this one works fine. So you're telling me that a motor designed to push somebody on a skateboard can't handle a 4-to-1 gear ratio on this fan blade? I can freely spin it with my hand. It's heat soaking a little bit now, but I knew something was wrong when I got up over half throttle and I started to hear it kind of wind down. Well, that sucks. Yeah, that's true. The vibration could have done it, but there was, I mean, I don't know how much vibration there was, except just from the gears themselves. So, looks like I'm gonna have to order me another motor. Alright. Let's unplug this. Try it again for prosperity. Just see where we're at. Oh no, I need those extensions on there. Interesting fail. But data nonetheless. At least I didn't lose the fan, right? I didn't lose the turbine. So, just the engine. So far, that's holding up pretty good. I mean, for something that should have blown up by now. Yep. We lost the motor. Yeah, I'll probably check the motor with an ohm meter after this. But I didn't even get to see how fast it was going. Was it pushing? Because I was behind something to protect myself. How'd it look? It definitely got up a little bit higher than I did last time, for sure. But maybe what I'll do... Yeah, that's weird. Let's take a closer look. We'll take a closer look. So let me get the drill. We will make sure we know what's going on. But I'm pretty sure it's the motor. Story of my life. Now I need a motor. I'll just send this one back. Alright. I think the next one I'm going to go for is going to be this, because this is a 190. If I go to a 100 kV, I think we'll have a little bit more torque to work with these gears. If I have to, I'll work on machining the gears down a bit so that we can have a little bit smoother run, but I really didn't want to have to do that. He was moving though. That's for sure. That's that familiar smell of the motor. I'll tell you that right now. Get these straps out of the way. Yes, I know. Shut it off. Power this off. Oops, sorry. Did it hurt any of you? Okay, here. You sit over here. It was definitely moving some air because I could feel it all the way back to at the other end of the shop. All right. Let me get you backed up here so you can see what I'm doing. Get this lowered down a little bit. Okay. So, as you can see, the gears, everything's still rotating like it's supposed to. Nothing bound up. Motor's still solid. I think we just lost. I think what it is I just lost this motor, which is fine because then I think the 100 kV has the same bolt pattern as this, so I wouldn't have to change anything except pull the motor off, and that's not a big deal. I'll look online for one, and I think they're. I mean, this was only 83, so not bad. Not bad for the motor. I think I just need a little bit more kV. That's going to drop the RPMs a little bit, but then I'm never going to be using 32,000 RPMs. Realistically, it's going to be anywhere between 25 to 30 at a max. Probably 25, 20 to do a hover. I think 15 to 20, easy enough with 4 of these. So, yeah. You can see everything's still spinning like it's supposed to. Nice and loose. You can hear that gear noise. And they're slowly wearing themselves in, so it's starting to get easier and easier. But my amps never got real high. So I think the motor was just either, just over torqued it, I guess? I don't know. That doesn't make any sense. Doesn't make any sense to me anyway. Let's go ahead and pull this. We'll get things to the point where you can take a closer look. And then get this out and pull the shaft out. Giggity. I got that on there nice and tight for a friction fit, don't I? Not the shaft, it's the this part right here, the motor mount. Let's pull the whole thing. That way it'll be easier for me to knock out. So that's these. At least we know the connection was tight, right? Now it looks like the Moonlander. Okay, let's set the fan over here. The fan fared well. Had all that extra lubrication from the inside of the gear. Everything's still good there. But this here, so this was always a little bit of a pain to remove. But then, you know, it's supposed to be. So you can see how everything's kind of meshing well together. Oh, I can feel something slipping in there on the motor. Oh. No, never mind. I'm dumb. Get that off of there if I can. Well, you know, it's not going to fall apart. It'll take me a minute to get this out of there. Let's see. We're starting to make some headway. Yeah. Getting there. It's a tight fit. That's what she said. There you go. This planetary. As you can see, the new mounting system held up just fine. Even at that RPM, no cracks, no breaks. So that held up well. Planetaries held up well. Didn't lose any bearings to speak of. Everything looked like it was going really well. And I think we just ended up losing the motor, that's all. So obviously, with the way it's designed, you can see how modular everything is, you know. You lose something, you just take it back apart and fix it. So we don't want to lose our motor mount. That's still good. Keep that over here. And there's our piece of shit. Actually, it did pretty good for a while. I don't know what went bad on it. We're gonna have to test it. Wow, that flies has mentioned before. But we have our whole fan. The whole fan, everything. Nothing failed. So far, I've broke one of these motor mounts, which I redid, and now this is fine. Works perfect. Gearbox, still working fine. Albeit noisy. And the motor is what I lost this time. Gears are good. I mean, you can see how they're kind of, that's that clicking noise you're seeing. You see how it meshes in like that? Let's see if we get closer here. You see how they mesh and kind of click? That's what I'm trying to wear in. You see what I mean? So that's what you get. So that's that clicking noise we're hearing in there. But there's not a lot of resistance at all. It's really easy to turn. You just hear it. And those eventually will wear in and work very well as far as a planetary gear system. Now, obviously, if it was made from CNC, I would take a little bit of the edge off in here where the gears make contact, where the gear faces make contact. I would take that little bit of edge right there off the corner, but just shave it ever so slightly. Then it would be a lot more, less noisy and mesh better. But other than that, I mean, the whole thing works still. So now all I got to do is get another one of these and check my Amazon account to see if I can return this. And then if they say yes, I'll send it back like it is. Be like, hey man, your motor failed. It didn't even get to 85 degrees. And it failed. Internally, I can't account for that. It may have gotten really warm on the inside. But for something that's 190 kV off of 48 volts, that should have been plenty of torque. Obviously, we've run this before. We've put it through some stuff, and it survived. So I'm thinking, obviously, we're going to have to go with maybe a 100 kV. Knock that 90 off of there. That'll give us more torque to work with. What do you all think? Give me your thoughts. They are invaluable to me. Yeah, they've seen my channel. You think they care? They'll package it, throw it on a return cart, send it back to the manufacturer if it's damaged, or they'll throw it on a return cart if there's nothing wrong with it, and which there obviously is. Somebody will buy it on a pallet somewhere. They don't care. I've sent back several motors. And I know that PXD's been around to see me blow them up. But it does give us time. It does give us time to work on the turbofan, which is sitting up over there in the top left of your screen, just above the fan. So, and I have the 650 kV for that. That's what I'm going to run. And see what happens. But that ESC, it's working great. I mean, that's probably the best ESC I've run so far, and I usually say that right before they explode. But that one actually does a good job. Well, I mean, yeah, I barely got over half throttle, so it's not like we were running like, you know, huge amounts of torque through it. And I knew that the run-in there would have to be a run-in. So, you know, that's why I kind of ran it a couple times first time. Wanted to make sure that the structure was stable enough. If the structure is stable enough to handle that thing during a wear-in cycle, like it just did now, then, I mean, the fan failed the motor. You know, that goes to show that the design is actually holding up pretty well on the fan end. Now I just need to go with a lower kV motor. I'll just get 100. I found one already on there. It's another Flip Sky. And it's 100. I'm not saying they're not reliable motors, but this one, I don't think it should have failed at that point, to be honest with you. But these are the things that happen to me. I'm not going to take it apart with snap ring pliers and pull the case off and do an inspection and so on and so forth. I'm going to let them do it. And I'll just get another motor. So, I mean, that was a fairly good run. I went higher than I have before. And it's because the first run had a chance to wear those gears in a little bit. And I can tell that they've worn in a little bit. So, it goes to the rigidity of Overture PETG, I'll tell you that. Yeah, that's a ratio I'm going to have to figure out. I need a decent load sensor to find out what's going into the gear movement and what's going into the fan or the air volume. Because you've got that 4-to-1 step up, and you've got, I mean, we already know it's 0.665 kilograms per second of air volume. So if you consider that, I mean, I wish I had something to test the load on the motor as far as I mean, I've got the amp meter, but it's just going to give me the amps. I guess that's okay for checking the load on the motor. But other than that, I mean, it was a good motor, you know, and I'm sure these things go out all the time since they're for skateboards. So I don't think they'll be surprised when I send it back. Well, yeah, I probably burnt one of the phases out, like you were saying before. So, I mean, you could fix it if you wanted to rewind it. But, you know, that's not something I'm getting into yet. I've been looking into motor winding to do my own, but, you know, I'm trying to find something, like I said before, off the shelf that you guys can get into yourself and get the components and then just put this fan together and have some fun with it, you know? So obviously we know it's the motor. You want me to hook it up with no load? We'll just test it. It's gonna spin all over the table or it's gonna do nothing. Either way, it'll show us what we want to know. I think no load is a good test. We can handle that. This is an outrunner, so we'll just kind of set it up here. And I'll hold the wires. Because I'm not going to spin it up real fast. I doubt it's going to do anything. I don't think it's going to go anywhere. So I'm not real worried. Oh, wait, no, that's wrong. Wrong plug. This one's here. There's the radio. I knew it every time. That denotes a problem right there if I have to calibrate it every time. All right, so kind of, yeah, it's a short. It is definitely a short across one of the faces. And that would heat up the ESC if it, for sure. So any of the heat that I got from the ESC was probably from that. Yes, I know. So that looks like a burnt phase to you, correct? I mean, anybody could see that. And group up all my hardware here. I don't lose anything. I'm like moving the lamp around. You're like, what is that damn thing? You all know it's part of my own rendition of the New Jersey drones. People will be taking pictures of those for miles. Especially when there's 100 of these sticking all out of the Shrike XL. So, all right. So that's where we're at. We know the phase on the motor. So, what do we do next? See if I can return that. If I can't, I'm eating the cost on that one. Knew eventually I would anyway. And I think that at this point, what we're going to do is go for a lower kV. I mean, what do you think? Should I go for a straight 100 kV? Or do you think like a 150 kV? Or do I go with 100? I think I should go with 100, to be honest with you. I think the one that they have is bigger. It's a one size bigger than this from Flip Sky. The only other thing I can think of is maybe using their ESC, because they have an ESC for it because it's a censored motor. And if they were, and I have the ESC there, or the ESC, so this must be just for the sensor control. I don't know if I'm going to have to order the whole control board for like the skateboard, you know, like the throttle and whatnot. I wasn't wanting to go that route, obviously, because you want to be able to use an ESC and a regular RX. But I think through Arduino, we could do something with this. I don't know if it's automatic timing adjust or if it's just motor sensor, reading temperature and telemetry, that kind of thing, for the onboard computer, for the control module, for whatever skateboard is for. But because it's just, you know, a standard 3-phase, it works perfectly off the ESC. So, but hey, we've got a Turbo 650 we can play with. So all I have to do is just print up a fan. Not a fan, I'm sorry. Print up an index. Realistically, it's just this part. And do a direct drive. It's like a slightly different motor mount that would hold that outrunner. And we know we spun up V1 with this ESC, this 48 volt, because it has that. I had the timing at 11.5, and that's what gave it more torque. So, yeah, that was fun. That was fun. Learning the limits of your hardware. Now, I have successfully destroyed a 190 kilovolt motor with a 3D printed engine, which is a testament to the build quality. I am doing well. And it's data collection, right? I mean, you know that, wow. I mean, that's what you're all about, the data collection. You know, you're always testing stuff like this. Your EDFs and your VTOL systems and your pitch and yaw that you've got on. I've seen some of your stuff. It's pretty, I like it. What we should do is implement some of your control on that and make it fly solo. That'd be fun. I can do an easy 22.2 volt version of it, and you know it'll push some air. I mean, if anybody saw Stubby V1, it'll push some air. The idea behind giving it a gear ratio and using a high torque motor was that I would be able to get more RPMs out of it. And obviously, once we move towards the alloy phase where we're doing the CNCing, we would already have the powertrain pretty much done. So, yeah. I don't have a lot more to add to it. I really would like to hear the input from the people. You know, was it fun? Did you enjoy it? We got up a lot faster than the last time. And as soon as I got about 2 ticks over half throttle, close to quarter, or close to 3/4, about, not quite a 3/4, but what ended up happening was I heard it start to slow down, and then I saw the smoke out of the back of the engine. I was like, ah, crap. If anyone can cook a 190 kilovolt motor, it's me. What do you mean, the precision equipment? Hold on, I'm trying to read past these. Oh, let me get these out of the way so I can see. I can't see that word. Hold on. Oh. Repeating the Shrike and tuning it well, but you know. The price. Oh, yeah, I know. No, yeah, I got you on that one. Yeah, I'm going to rebuild the Shrike just because I want to rebuild it and have it around when I have a little bit of extra money so I can play with it, you know, while I'm working with these projects. I'm going to tell you what I want more than anything, because I obviously can't fly small warbirds. I was good with, you know, the Switch. I don't know if you ever saw the Switch RC plane, which it could be a bottom wing or top wing. So it was easier, you know, it was great as a trainer, and then you could switch to sport mode, you know, put the wing lower. And oh no, I see what you mean. An interlocking one that's already printed together. That could work. But you just got to figure out how to implement the carrier that's going to spin the planetaries. So it would be like what I did there, you know, add 10mm bearings, get a 5mm carbon fiber rod, and then make some kind of rotator that attaches to the engine that you're pushing it with. But like I was saying, I flew with the Switch, and I had the Super Sky Surfer. I got into Nitro, did that for a while as far as, you know, just planes. First drone I ever had was like a 350 QX from Blade when they were selling those. Old school drone. And then I really got into the sailplane, the powered sailplane gliders. I love those things. And the one that I really want to get is that 3000mm Fox. Because that thing just sings through the air. It's got the weight, it's got the frame for it. I mean, it's just a beautiful, beautiful powered glider. And the powered aerobatic glider. I mean, come on. You can't go wrong with that. I would love to get that thing, but, you know, I've got to get a better transmitter for that because I'm running ELRS on the TX16S. So I can't use it for that unless I put a you know, another flight controller into it. But I want to kind of go with the plug-and-play version of it so that I can kind of just get a Spectrum radio so I can run the flaps and run everything else I need to. So, you know, get a nice Spectrum radio. I used to have, you know, I think a DX8 or something like that. But I need to get a good Spectrum radio so I could run that Fox glider. I mean, if anything, that's what I would love to do. Take it to the park, fly it, you know, while I'm printing parts for hours. Fly that thing around. AR Drone 2. Why does that sound familiar? Planes are easy if they're bigger. I'll tell you that right now. Don't start with a small. There's a lot of people will be like, start with a small trainer. No, don't. Like, get something that's 1,500 millimeters or more, and start with that. And the reason why is because you're dealing with the wind factors. You're dealing with the weight of the plane, and the weight of a larger aircraft is way more forgiving when you're training, learning how to fly, than some of the smaller ones. But the stitch, not the stitch, the switch, I forget who makes it, or even if it's still being made. But the switch was a really great aircraft because you could go high wing or low wing. You could switch it. So you could train on the high wing trainer and then go with a low wing, and it's straight when it's on the top, but when you input the wings on the bottom, it's dihedral slightly. So you get that. So you got that stability. That was a great plane for me to train on. It really was. And then I just modified it, put a bigger motor in it. I was flying it at a sports park, and something happened to the front end of the motor mount, and it just came off, unplugged from the wires. And I was flying. The motor fell off, and I flew and landed dead stick. Not dead stick, no motor. Okay. And I glided it in, and for some reason it didn't mess with the CG when the motor fell off. But I landed it. I landed it with no motor. That was just too funny. I mean, you modify stuff when you get to the point you get bored. You modify it. You make it work for you, and you're like, okay, this thing needs more power. So like on my Super Sky Surfer, I put a bigger motor on it and a bigger prop. And then the prop was too long, so I cut the ends of the prop down and then balanced it. And I had like this monster prop on the back. And that Super Sky Surfer was so much fun for me. It really was. And that's why I want that Fox 3,000 millimeter. That's like, what, 96 inches of wingspan? That's insane. It can take off from the ground. It can hand launch. Obviously, I have no other pilots to help me do anything, so that are close by, so I'll probably take off from the ground. It's got wheels on the wingtips. So if it, left or right in banks, you just basically got to rudder yourself into a straight position and give it some throttle and get it off the ground. But that's a fun plane. I mean, that's a beautiful plane. That's what that is. So that's what I'd like to get next. First, I'm going to have to buy another motor because we've got more work to do. So this one's bigger brother is roughly the same price, but it's 100 kV. That's what we're going to go with next. Same bolt pattern, so nothing has to change. And even if it did, it wouldn't matter. It would take, just a couple hours to print that. But the mount held up. Filling in those weak points right there helped a lot. It fit into the gearbox real snug. And then it bolted to the back of the stator casing perfectly. So everything worked. Everything on this thing worked. Probably would have kept going if that motor hadn't failed. So that's another success. And that is what we're looking for. That was another success today, and I am very, very happy with what's going on here. Not so much here, but here, yes, everything is working out great because it worked. Nothing in this thing failed that I designed, except for the motor, which I didn't design. Imagine that. All right, well, hey, thanks for stopping by. Welcome, everyone. Bree. Am I saying that right? I think if you're just getting here, you already missed the spin up. You'll have to go back to see it. We burnt this motor up. That's a surprise to me too, because that's a chunky motor. But this works still. Yeah, you can see where it kind of binds up. Just ever so slightly binds up right there between the tooth walls. And that's what we're going to wear in. I may set this thing on a drill and just like hold it in place and just zip tie the drill on and just let it run for hours until it's smooth. I don't want to reprint the gears. I need more filament. I ran out. Well, if you think it's beautiful now, you should. I don't know if you saw me spin up, but scroll back. You'll see it. The gear resistance is a terrible idea. I agree. Gear resistance is a terrible idea. I designed the gears for CNC, not FDM. The reason why I did that is because I didn't want to design 2 sets of gears for when I print this out for testing and then CNC it. So wearing it down to where everything's meshing well is what the plan was. This one uses a floating ring gear and still spins 4-to-1 with just a twist of a finger. Very light. Because there's a floating ring gear, much smaller gears, and they're interlocking double-sided helicals, opposing helical gears, it spins this fan very fast. So I'm going to make an adapter for this to run on my 650 I got laying around here. And we'll burn up the 650. See what happens. Or we'll do direct drive, maybe, because Stubby V1 was very, very fast. Had a lot of torque. And you can tell what I ended up doing was running it through that 150 amp ESC that I have here from, it's that Fly Dragon ESC, the 48 volt. So when I ran it through there at 11.5 on the timing, it unlocked a lot of torque in that 650. And I was holding this fan when it exploded. Oh my gosh, that was the day. But this one still has the low pressure turbine system in it. Every one of the fans besides this one right now and the other front drive fan has the rear stator that goes into the exit aperture here and the low pressure turbine with 5 blades. So you can kind of see them in there. Kind of, sort of. Oh, from the back, you probably can. Let me open this. So you can kind of see them in there. So yes, a lot of work to do. I do have a couple of end pieces that will go on the back of the turbine. This is a mixer. This would be if I was burning fuel, but realistically, at this point, running a low pressure turbine system at the rear is just going to assist in torque overall, especially running off the same central shaft. So that's really the idea behind that. Now I've got 2 sets of those. This came off the twins. Ran out of filament, so I was using different colors. This one looks like a soft serve cone. But serve the same purpose. It's basically just a mixer. And it's supposed to take hot gases that are coming out of the compressor section and mix it with the high pass fan air that goes over the top to reduce noise. So at this point, right now, the idea is we are running everything here in rear drive. So the back of this fan casing, the back of this stator casing is designed to basically index the sun gear on this planetary. And then it bolts into place and then spins the fan. So the motor mount goes on top of that, as we've seen before, like so. And the motor gets indexed into the collet. And away we go. And away we went today. And we burned up a motor, which I am still surprised at. I almost want to take it apart and look, but I doubt I'd be able to find my snap ring pliers. That's my life. Where are my tools? I'm gonna have to go over and watch it. I believe you that it was awesome, but I'm gonna tell you right now, um, because I've had fans explode on me before. I was over there, like in the back corner over there, behind that metal table, down low, so that if anything blew up, I wouldn't get injured. So I'm gonna have to go back and watch it. Yeah, the compromise in FDM printing is always that you have anything that's made for CNC anything that I cam out of Fusion to be CNC'd is basically designed for whatever machine I'm going to be using. So if I'm going to use the Pocket NC, for example, I know the tolerances of the machine, so that's what I'm going to do. I'm going to design it to those parameters, your machine parameters. So when you FDM print, you have to compensate, obviously, because the print line is going to be 0.2 millimeters on either side of the actual model wall line. So your extrusion is going to be at least 0.5 over when you have two intersecting walls. And if you have four intersecting walls, like two sides of a tooth gear, intersecting with another two sides of a tooth gear, you got 0.08. So you're almost a millimeter of extrusion that you have to compensate for. Now you can squeeze them together and they'll fit. They'll just run really tight until you they'll run really tight until you actually run these gears in. So that's why they sound the way they do. But they do sound a lot better than they did before. So the idea is get these worn in, clean them out, add more Interflon is what I'm using, and it's a great lubricant for this. Otherwise, it probably would have seized up by now. But I'm gonna wear this in, and then I'm gonna have to either take out a huge loan, which I probably won't qualify for, because nobody gives loans to veterans anymore. They don't have the income to try and get this CNC, or I'm gonna have to send it out and have it CNC'd and hopefully ensure that when they take the BRB or the solid body and I package it up as a step file or an IGE or what is it? IEGS? Yeah, IEGS. Aegis. That their system can read it. Because what I tried before was to send stuff out to get it 3D printed, or CNC'd rather, and they gave me it back, but the problem was we had the tolerance for this being aluminum was too high. They're like plus minus 0.3, and that's ridiculous. That's way over. That's too close to a millimeter offset for gears with that kind of design. So I was sitting here trying to grind it down with like lapping compound and a drill, just running the planetaries in it to see if I could get it to work, because the planetaries mesh well together and they're finally straight, because there was a lot of meat I had to take off of the sun gear, and these are all done out of aluminum. So when I had them printed, I'm almost to the point where I'll try and show you. Almost to the point where it goes together, clicks into place like it's supposed to. And it shouldn't move. It should click right in there. Oops. supposed to move, but that's not my point. You got to get it meshed in with the gear, and that's the problem with a double reversed helical, is they're harder to lock together. Okay, so once you do get it in there, okay, so that one fit in there just fine. So I get this one in. If I lock it down on one side or the other, let's say I go here, that's the gap I've got because of their offsets. That's, and like I said, it's over $1 because you got all these sides to consider when you're talking about the planetary. And it would work if I could basically just put some, like I said, what I was doing was zip tying this together and running a lapping compound inside the teeth, and then just running it with the drill. And then the gap was wider than this before I started. So, but ultimately I think this is a lost cause, $114 lost cause, because I tried my best and I couldn't get it to null out. So, 3D laser sinturing is just not what you want to do with these. They need to be CNC'd. So, and that, the one I showed you before basically is the same thing as those gears there, but it's a single drive floating gear on the inside of this box rather than a full stack. And it's just really smooth for a 4-to-1. So the idea is there. And since basically I can take this and go, okay, I'm not using that one right now, I'll use this one. And then bolt everything together. So that's what this test ductwork is for. Typically, if you were going to use this on an aircraft or any other project that you wanted, you would take this engine complete with the motor, the mount, and everything after it's CNC'd and everything's reliable, and you would drop it literally into any plane body that you would want to build of this scale. And you're going to get a thrust to weight ratio that is higher than you expected. Because this has a max thrust of about 55 pounds. Oh, guys. So, anybody have any questions about what's going to happen next? We both know, or both. I'm like both. Like there's two people here. Like I expected a low audience already. I'm all, both of us have been watching this for a while now. I'm sorry. I crack myself up sometimes. What are you going to do? It's raining outside. I'm stuck in here doing stuff. Planes over there, plants over there. No, those are vegetables. Don't get your hopes up. Working on the MPCNC, working on this thing. What more could a grown man want than to act like a child, right? Well, yeah, they don't. I mean, I agree that most people don't fly big planes, and the reason why is because they're expensive and they can be boring. I understand people want to do aerobatics. I'm more of a classical flyer. If you saw the introductory video on my channel page, you'll see where I kind of started from, and then I kind of got into drones, but I was really into the big planes and rockets, that kind of thing, just the fun stuff. But like we're talking not like the sugar like you do in school. We're talking 2-inch AES pipe, 15-inch long, put together in core sections with a 3/4 inch dowel rod hole in the middle, peppered with powdered meal powder, black powder, so that the entire core lights, and a strip of magnesium that goes down the core so you can track it, because there was no way in hell I was going to track the thing after I launched it. And when it took off, it was gone. I mean, that thing was a surface-to-air missile. No joke. So when I do that again, I want to build a big body for one. Hopefully, get some of it back, and it doesn't land on anyone, and at like Mach 4. I'm telling you, that thing was quick, and it was just an engine. I like set it up like a bottle rocket with just a dowel rod and then 2 big fins that I made out of balsa, shaped them, put them on there. But I do agree that most of the big planes, I'm not talking like really big planes. I'm talking like super skyscraper size. Anything from 15 to 2,500 millimeters on the gliders. The jets, dual 70 millimeter SU-47 Berker, something like that. I would love to have. Not real big planes. That's not what I mean. I don't mean like the big ones where you're having to run kerosene jet engines in them and stuff like that. I don't want to do that. This is my answer to that kerosene jet engine. So, I'll have to check that one out. I'll definitely check that one out. From Great Plains, I will check it out. But I do still want to get that FMS Fox, because that's a beautiful glider. It really is. And it just sounds so sweet coming in. Like if you come in from like if you go vertical and you rudder, port or starboard, and then you come down and you just let that thing fall and then pull out of it straight over the runway, you can hear it just whistle as it goes by. It's just awesome. It's a beautiful plane. Very well balanced, very well constructed. Easy to put together because it snaps together. Like literally snaps together. You don't have to hook any wires up or anything like that for the most part. Oh, wing songs, yes. When you hear that thing whistle as it comes by, and you got one tone or multi-tones, it's just the most awesome feeling. You're like, I'm unpowered flying this thing, and it's just whistling on by. And then you hit that power up and go back into a vertical climb, do a loop, come back around. It's just, I miss flying. I've been doing this for, my research purposes and my drone project. And then ultimately a vehicle that you can ride. There's a lot more in the works. A lot more that I haven't put on YouTube yet. Some hydrogen-based stuff. So on and so forth. If you guys know what I'm talking about when I mention hydrogen, you know exactly where I'm going with this. So, Animal, are you, do you play Star Citizen? Yeah, I don't want to do 400 miles. I want to cruise with the glider and have some fun. And it's nice to do a fast pass every once in a while, but, I'm not looking at, a glider doing 400. I'm more or less looking at, with the projected thrust to weight ratio with the body I designed for this, I did an SR-72 Dark Star body replica that fits 2 of these engines. So we're looking at close to Mach 1. If I can get it carbon fibered out and I can get the leading edges done in something that's not going to melt. Well, let me show you something then. Because this is also part of a weight mitigation system where you put two of these in the bottom of the Cutlass Black and you make a large Cutlass Black. Now, over here, for the rear nacelles of the Cutlass Black is the turbofan right here. Stators are already printed inside. Cores, I had to reprint the cores. That'll be driven by probably a 650 or 800 kV. Probably going to go with the 650 because it had a lot more torque. That's going to be for the articulating nacelles for the VTOL. And over here is how big she's going to be. So weight mitigation with two of the 170 millimeter fans. Engine here, and then the two articulating nacelles on the back. This is so I can do a mold, but it got messed up because I have two Huskies. So they're like, ooh, big chew toy. You know, so basically this is like what I'm building. That's how big the ship is that I'm building that I'm going to fly when I do the Cuddy Black. Not messing around with that one. So all of it takes time. And getting this perfect is crucial to that. But the great part about it is I don't have to get the RPMs out of this that I'm expecting for forward flight for if I'm just using them for gravity mitigation, so that the four engines in the two in the nacelles and the two in the front can do their work as a drone would. This would take off VTOL. I would have the landing gear retract just like on the Cuddy. The back door can drop down, side door can open, so on and so forth. Yeah, I'm going for Mach 1. So it's a big project, but that's why I built the CNC. It's one of the reasons why I built this. Not this plane. I designed this and built it with a 90 millimeter, but right now I'm just waiting for parts for it. But I can tell you right now, I 3D printed the CNC, and it was smaller, but I needed a bigger table, so I designed it to be a bigger table. And this is going to be how I cut my negative molds for my carbon fiber parts for the SR-72 Darkstar. Colt, do you want to go outside, buddy? Come here. Come on. Let's go. Let's go. Come on. Let's go. Let's go. Bye-bye. It's raining. Don't slip when you come back in. Wait, hold on. I gotta unlock it because he'll decide when he wants to come back in. Yeah, so you see, you always do that. You just bust right back in like you're the boss. Why you gotta do that? What'd you do? You didn't want to go outside to go to the bathroom. Come here. Say hi to everybody. Say hi. You're gonna slip, dude. I told you. I told you you'd slip. Don't run. Dog's too funny. Yeah, he slipped. He turned around. He went. He went out just for a second, and then he came right back in because you know how he likes to kick the door open like he owns the place. And then you know what? We're just gonna wait until he does it again. Sorry, the back of the garage I still have to paint. I'm working on it. Can you tell I have children by the artwork on the door? So yeah, he slipped. Let's see if he busts in though. And now he never does it when I want him to. Like on camera. Oh yeah, come in all gentle like. Yeah, because you slipped the last time. That's why. I tried to warn you. All right, let's go. Say bye to everybody. Okay, let's go. In you go. That dog. Tell you, he's an awesome dog. But you know how huskies are. They're not guard dogs. And if he gets excited, he screams. Like, not even a howl. It's like he's trying to bark like the other husky, because we have another husky. And she barks because she's more coyote than husky. So she tries to bark, or she barks, and then Colt tries to bark, and it's just like a it's like a big old scream. And if he gets too excited, he starts screaming like somebody getting murdered in an alley. It's not even, no joke. It's the loudest thing I've ever heard in my life. But yeah, that was... He does that, man. This time he comes in all gentle-like because I'm recording. But sometimes he'll just jump up, hit that door, slam it against the wall. That's why I had to put that there. Because he doesn't like his chew toy, I guess. Because this lock I had on here, he rams it into the wall every time. So I have to... That's what I have to do. I have to put that in front of it so stop it from destroying my wall. But yeah, he's kind of a klutz. Like, he'll run in with wet feet and think he's got traction. It's the funniest thing I've ever seen in my life. So, yep, he's a funny one. Well, I'm not sure what else to talk about except, we did the test. I got to get another motor. So in the interim, I'll be working on the Black Pearl and getting her all done. And then, sorry, my inspiration is in the shot. Yeah, I'm still working on this. Got my wires run for the lighting. You guys know that. You've seen it all. It's the other side that's beautiful because I've weathered it already. So, yeah. She's going to look good. Still got a ton of work to do. A ton of work. Let me get that locked back in there so you don't fall over. Yeah, I'm going to do the rear cabin after I do that. And then I got to do all this stuff. Oh, yeah, I just got to get the walnut wet and then heat it up around the iron and bend it. So now I have to bend wood to get everything in there. It's got beautiful brass pieces and oak pieces for everything. It's got the masts. You've all seen it before. But for any of the newer viewers, I've got to tie all this rigging. And I don't even have to tie just that rigging for the mast. I have to tie the rigging for those. It shows me step by step how to do the rigging. And all the tackle. And every other small piece. Because this is beautiful right here. As I dump everything on the floor. Got the lady for the front. The anchors, which I think are really cool looking. The deck cannons, which are coupled with some of the walnut wood. And then this is the side cannons, so they just go into the portholes. Tackle, accessories, all the flashing and everything. The Poseidon statues at the rear of the ship. The lights that go on the rear of the ship that have the wires running for. And all this little detail work. And those, just beautiful. Just beautiful. So, it's a work in progress. It's the kind of thing that takes a long time. You don't rush it. But, it's got seriously beautiful detail. Especially in the cannons. Take a close look at the cannons, if I can get a close look at the cannon. Will it zoom in? Will it focus? I don't know. You can kind of see it. It's got the markings on it. These are what go under the... You've seen these before. These go... There we go. Hold on. There's the bell. And then those go and support the back end of the captain's cabin underneath. I'm sure you've seen the ship before. Who hasn't? But yeah, lots of rigging to do. It's gonna be fun. Lock that up. Okay. Whew. Well, I have some work ahead of me on this one. Yeah, I got sent a bill for a parking ticket for a car that I don't own. And that's what this paperwork's for. I won't show it to you, but it's from Oakland. And I'm like, I don't even own a Suburban. It's like, what's going on? Apparently I own a Suburban. But yeah, like this. I got to do all the rigging. It shows you how to do all the rigging knots. Some of it I remember from my rigging class when I was doing commercial diving. But for the most part, some of this stuff is just old school rigging. Like seriously old school rigging. Well, yeah. Nothing like diving in LA Harbor. I don't want to do that ever again on purpose. I also don't want to ditch in dawn again ever again. When I was training there for the underwater welding and everything, we had the Vader project, they called it, and it was just a pipe complex or an oil pipe set. We had to basically go and find all the pieces using search signals with our ropes up to the tenders at the surface, and then we'd have to go out farther, and then they would tug the rope. Certain numbers of tugs, things like that, were certain signals. We had radios, but they wanted us to learn signals. Oh yeah, the ship's gonna look beautiful when it's done. But when you have to ditch in dawn for one of your final parts of your exam, your test, I should say, you have to take your. I had a Superlight 17B, and I had to uncam it, take the helmet off, let myself be saturated by water from LA Harbor. Then I had to put the helmet back on, keep my composure, cam it back together, and then crack the free flow valve to push the water out of the helmet. And that's just in case, like, you have an accident where you get your helmet pulled off or something like that. You know how to put it back on and then recam it and then push the water out so that you don't drown. I think that's one of the key factors of keeping a job such as that, is not drowning while you're doing it. So, but yeah, I had enough. I had enough of commercial diving. Because when you're cutting with a broken rod or something like that, and you're underneath there, and you're like, you got to watch for air pockets that are building up, because you're basically electrolyzing the water. You're separating the hydrogen and the oxygen, and they mix together. And if they pool up anywhere under any that you're working on, and you spark it, it'll explode. I mean, and when it does, it's like getting hit in the chest with a. Because we've done that before. But anyway, I've been on for about 95 minutes now, and only a couple of that was the fan. I hope it was worth it. I got to go back and watch what I missed, because I'm going to be honest with you, trying to protect myself from any potential fan explosions, I didn't get to see what was going on. I was just going off the sound. And I knew we got farther. So, all right. Well, if you haven't yet subscribed, please do. And please share with your friends, because this is how it helps me get the message out. Gets more people to come on in, gets me more subscribers, gets me the watch hours, so that eventually that this channel can help me monetarily to continue to support this channel. Because all of my money goes into this. All my brother's money goes into this, sometimes when he doesn't know it. And I need to be able to continue. So the idea is, and I'm not ashamed to ask for people to join up. And once I get to the point where I get like the super chats and stuff like that, you guys better have your wallets ready, because I'm not afraid to ask for it, because they ain't give me diddly shit for vet benefits. So, I mean, and you know, I'm over 50% service connected. So, you'd think they would care that I can't afford eggs. But other than that, it doesn't matter. The point is, if you guys are interested, you're willing to help, you want to help, I have links for the Buy Me a Coffee website where I can transfer stuff over whenever, you know, save up what I can, get supplies that I need, more filament, because I'm not doing it just for me. I'm doing it for all of you. So, I mean, to be perfectly honest with you, PXD probably owns this. He probably owns this. You know, with what he's helped me with, you know. He probably owns most of what's sitting on this table. As far as filament and stuff goes. So I couldn't do it without all you guys. I really couldn't. I order what I can when I can, but I gotta pay the bills, and I gotta take care of my girls and my wife, and make sure everyone's happy and that the rent's paid. So I get what I can when I can, and then I build what tools I can't afford. I build using the same technology I used to build this. So with that, we will wrap it up. We are getting some degraded signal. It looks like there's a really bad storm here. The fact that I'm still online surprises me. I'm expecting the power to go out soon. We've had some pretty good sized hail over the past few days. It's been raining and windy like crazy, and that's not good, especially because my car has a Hemi in it, and I can turn off traction control, and it's just way too much fun. But don't do that. I'm not suggesting you do that. Be safe when you're on the roads, especially when they're wet. Watch where you're going. Leave the traction control on. Okay? Don't do what I do. I do it when no one's around and when there's plenty of space, but just don't do it. Okay? It's not a suggestion. It's a warning. Be careful out there. Because I know a lot of other people out there got to deal with ice on the roads. And that's not something I have to deal with all the time. I can only imagine what that's like. The only time I get to see snow is on TV. So I feel for you. You guys having to deal with snow and stuff this last winter. You're probably still dealing with it. Love all you guys very much. I thank you for all your support. Please, like I said, subscribe, leave a comment. If you have suggestions, you can email me at my email that's on my channel page. I have a Patreon. I have the Buy Me a Coffee link on there. I have an Instagram. I have a Facebook. So all that's available. I try to get videos up on those when I can. But realistically, everything happens here on YouTube. So everything you do, even a subscription, even subscribing, is more than enough for me. So I appreciate all of you. And with that said, I am going to go try and figure out how to get another motor. First off, I'm going to see if this one's outside of my Sinback window. And if it isn't, it's going straight back to the manufacturer, because I didn't get over the amps I didn't get over its max amps. So, and they don't know what I use. I mean, if it's supposed to push a human being, then it should be fine. With this. So thank you all for all your support. You've all been wonderful. Thank you for all stopping by today. I hope you enjoyed the content. I hope you enjoyed the fan. It will be a finished product soon, where it will be available in STL files, and then eventually an alloy version, which I will put into production, which will be very inexpensive compared to, like, say, Schubel or things like that. But without rambling on and on even more, because my ADHD is starting to take over, it's time to get out of here. So you all have a beautiful weekend, and I will see you all again very soon. From all of us here at DPC, which is probably just me and PXD, and of course the wife and kids. I'm rambling again. Love you all. Bye.